Okay, let's do the question 20. Any three vertices of this cube shown in the figure below can be connected to form a triangle. For example, vertices PQR can be connected to form isosceles triangle. So let's just go draw it here. I'm going to change it P to Q to R. Why didn't it say equilateral? That means they're not all three sides are equal. Only two are equal. So this one is equal to this one, but this one PR is actually larger because it's going diagonally. So what does the question want? How many of these triangles are equilateral? All three should be equal, and they contain P as vertex. Okay, so we just want the ones that actually, go from P. At this stage, it's advisable to just go and just check the options. There really aren't that many, and 0 is even a possible option. Good. So the worst thing you could do at this stage is just try to just draw any triangles that are possible. Just you're thinking without organization, and that's not good. So first you need to ask yourself, how many different sides of different legs can I draw? Like any of these pairs are possible, right? So for example, I could go from S to Q, I could go S to P, I could go S to R, I could go S to U, I could go S to V. So we have to compare these lengths together. So the smallest one, if you agree, are these, okay? A side of the cube. Something larger would be this, to go diagonal. But there is also another one that is even larger than the red one. So imagine this is your room. You're going from the ceiling of a room to the opposite floor of your room that you're in now. This is definitely the largest one. Because it's set equilateral, we have to just use all three should be blue, right, of the same length, or they should be like red kind, or should be orange kind. So the smallest is like this. These are sides of the cube. So if I go, for example, 2, but if I want to connect them, then I have to go diagonally, and it would be a red kind. So it's not going to work. So I can't use the sides, all three sides. Okay, so I have to go with another one. And again, let's go with the kind of blue. If I go from here to here, how can I continue this? I could either go like this, which would be a side, small. Even if I go diagonally like this, it's still small. This is the red kind. I'm still on one square. Okay, so right now, so far, I have no options. The only one that is left starting from P would be, for example, I go to this R, and then I go to this V, and from V I go back to P. All of these are the same sides, okay? So I have one, that means this option is out. Can I draw more? I'll change my color. What if I go, let's see here, from P I could go to T, and from T I could go to R again, okay, and I could go back here. So that's 2. So this one is out as well. So here I had one of my students I checked the questions with. He stopped at this point and said he couldn't find another one. Okay, so he chose 2, which is wrong. But it was kind of obvious that 2 is not the right choice. You see, a cube is symmetrical. Okay, and triangles passing P should also be symmetrical. What do I mean by that? So here, from PR is 2, right? Red and blue are going here. But PV is only 1. And RT is only 1, right? Definitely there are more, because Once we're done with the question, because the shape is symmetrical, everything has to be equal. So there has to be at least one more. So let's go and check. So I could go again, P from here, PV. I could go from to here, VT. And then I could also connect this. This will be again another one. So now if you check, so the lines that are going through P, the lines containing P, you see I have blue and green. I have green and red. I have red and blue. See, now we say, okay, everything makes sense, like 2, 2, 2. This could be a possible value. And if you look for it, there are actually no more triangles to be drawn. So 6 will also not be the option. So we're going to go and choose D.